So this week we're going to cover some very basic statistical methods that you can use to start understanding sort of the shape of the data that you're working with and doing some fundamental analyses on it. We'll probably go into some more sophisticated statistical methods later in the term, but just as a baseline, I really like to start with kind of the basic measures of centrality and spread. And fundamental to these is understanding the shape of the data that we're working with. So all the time as journalists, we're going to get inundated with numbers, particularly numbers that people claim mean certain things. And of course, our job is always to be able to independently analyze those numbers and determine whether or not we think there's basically something worth pursuing. To demonstrate this, we're going to use Python and Matplotlib and NumPy and a couple of other things, just to kind of map out these basic statistics and sort of demonstrate what they look like when they're on an actual data set. So to do this, I'm going to go to the New York City Open Data website. You all are familiar with this. And I'm actually going to look for, this is one of my favorite data sets to go to, is standardized test scores around New York City. So this is a 5-year-old data set, but apparently it was just updated. And, we can tell, we can, just take a quick peek at it here. We see that it's not too huge or anything like that. There are some inconsistencies. There's a number of schools that don't actually have SAT data available. I also noticed that there isn't a total score in here. So that's something that I'm going to want to create, because one of the questions I might ask is, what are the best and worst performing schools? What are kind of the cutoffs for that? If you get a number like the average SAT score in school X is 900 or 1,000, you need to be able to evaluate whether that is something worth reporting on, right? Like, is this a big deal? Is this something we should be paying attention to? So first things first, obviously, I'm just going to download my data. And where's export? Here's export. And as I said, I'm actually going to use just kind of plain old Python for this, with a little bit of help from Matplotlib and NumPy. You are obviously welcome to do your analysis in whatever form and format you see fit. I actually tried working with this with pandas. I'm not a pandas expert, and frankly, it was driving me nuts. So I declined to keep doing that. So I'm going to go ahead and move this into my folder here. Whoops. Show in folder. Oh, you can't see that. There you go. Okay, so I have my SAT results here, and now I'm just going to open up a new file and just save this as let's see. Oops, I hate it when it does that. Come on, folks. SAT analysis. Okay. So first off, we want to import our libraries. So again, many of you may be familiar with some or all of these. I'm going to import CSV because that's how I'm going to parse the data coming in. I'm also going to import NumPy. And I guess the convention is to import it as NP. And oh my gosh, except for autocomplete, which is driving me nuts right now. Okay. Let's just skip that, everybody. Everything will be fine. And then from Matplotlib, I'm going to import the plotting function. So I'm going to do, it's import Matplotlib. Until I don't do this very much. .pyplot as plt. And finally, I'm going to import the statistics package, which is part of which I think just sort of comes with Python 3 and has some basic stuff. I mean, it wouldn't be a big deal to not import that, obviously, but it'll make our lives a little bit easier. So the first thing I'm going to do, obviously, is just open up my data file. So again, I'll use open here. As I think you've seen me do in the past, I tend to open, let's see, what are we calling this? SAT results.csv. I tend to use the RU command which is read lines universal, and I just do that to avoid any issues with different white space characters at the end of lines. So obviously I'm opening that as a read file. I'm now going to make it into a dictionary reader. So I'm going to say data reader equals CSV dot dict reader. And that's basically just because it'll give me access to the field names and things like that. It's actually not a big deal in this case. It makes iterating over the data a little bit easier. And so I'm going to demonstrate good practice here. So open CSV. So as I said, I was doing this with pandas briefly. I don't use pandas a lot, and I was absolutely banging my head against a wall how to get the data objects to convert to numbers, which seemed to be stymieing me significantly. So I did what I tend to do, which is I fell back on the most basic methods, which is simply to create what I want in, kind of basic Python. And so in this case, what I'm going to do is say, I'm going to say for every row in the data reader, I'm going to first try, because what I want to do is I want to build the totals. So total SAT score for each school. Now, as I'm sure you all have encountered, we have to examine our data a little bit. You have to inspect the data a little bit. You can't just sort of sit down and start writing code and expect that everything's going to go great. So one thing, even if I just eyeball this, is that I noticed that some of them in the scores or in the numbers don't actually have numerical values. I could just actually see this right here. As I scan through, I see these S's, and I did a little bit of background research, and it seems that there might be a number of reasons why those S's appear. Some of the schools are newer, and so they didn't necessarily have a graduating class, a class of seniors to take the SATs or a class of juniors prepared for the SATs in this year. Some of them may simply just not administer them, or their students don't take them, or they don't report them. That obviously would be a job of additional reporting to figure out what those S's mean and what characterizes the schools that don't have those scores. Because if your interest is in learning about kind of what the context is of, what the context is citywide for SAT scores, you need to know why, obviously, there are data points that are not being included in your analysis. But if we stick with just the ones that have numbers, for now, we can at least do analysis on that distribution. Then we may have to, we can start with there and then look at doing the background research to kind of fill in the blanks where possible. So I know that I'm going to have some bad values is the point, right? Which is why I want to make sure to go through the effort of having a try and accept statement here. So what I want to do is I'm just going to have an array that is the total scores. And what I'm going to do is I'm just going to literally go through and just try to cast the numbers, try to cast things as an integer, cast the data as an integer, and if I can't do that, then I'll just pass, right? I'm just going to ignore it. So for those schools that don't have data, I'm just not going to worry about it. So I'm going to say total scores append. Right, and the nice thing, of course, is it doesn't really matter to me, because what I'm going to ultimately get here is a histogram. It doesn't really matter to me what order these happen in, so I can just kind of take them as they come. So I'm going to be taking the sum of, first I'm going to cast it as an int, because it's not an integer already. And I also don't want to mess with the field names here. So handily, the dict reader the dict reader method creates a field called field names, automatically takes the header row and converts it to field names. So I'm actually going to use that to use an index to access it, because again, if I look at my data set, I can see that the header names here are like really ugly. I don't want to mess around with them. I'd rather just go by indices. So obviously I'm looking at 3, 4, and 5 are the indices of the columns that I need. And so I'm going to come here and say, let's see, it's going to be data reader dot field names 3. So hang on. First, we're going to cast that as an integer, but we need it to be, no. So row, the row is that one. So that's the actual data. And then I'm going to cast that as an int. And then we're going to see if I actually did this right. Right, integer, so data reader field names, that's the column name. That's the third column backwards. So that is the correct thing. And then we're going to cast it. And we're just going to add the other ones. So again, if you prefer to actually use the field names or to rename the columns or use whatever you want, again, this is just sort of to demonstrate the case here, right? I could also, to be perfectly honest, have just done this in a spreadsheet, which in this case would have taken about 15 seconds. But for the sake of cohesion, I'm not doing that. And so, so I need to have my except statement in here because, again, I know that there are going to be errors, and I'm just going to pass that exception. And if things go well, I will use my tried and true debugging method, which is to print the results. I think that's right. Let's find out. Okay, whoops. Let's get a new terminal. Oops. Okay. Okay. So looks really, folks. So looks okay so far. I'm getting things that look like they may well be totals of those numbers. I can obviously, I probably want to do a spot check and just eyeball. 1122 looks like it's probably correct for the first row. And so that's great. I now actually have the total scores. So the question that I'm asking here is, for any given value x, is x unusual? Okay, that's really the basic question that we always want to answer. Whether it's somebody who brought a number to us and said, oh my gosh, have you heard that this was x? Or whether, you know, we've picked it up on our own. We want to make sure that before we start writing a story about how extreme something is or how unusual it is or alarming it is or whatever, that we've actually done some analysis, right? And we know what the context of the data is. Ideally, obviously, in this case, as in any case, you know, you wouldn't want to be looking just at 1 year, but in multiple years. I mean, there's actually a lot of work to do to make sure that the number that you choose to highlight, or any number that you choose to highlight, is actually representative in a meaningful way, right? So this is sort of the first step. We're grabbing the totals. Next, what we're going to do is we're going to actually look at the distribution. So we're going to just make a quick histogram because we want to get a sense of what the distribution of these scores looks like. In other words, is it normalized or is it skewed? Because one, that's going to give us a way to judge whether what measure of centrality and spread we should be using to evaluate this data set. Also just, I mean, that's basically it. But that will, then when we map things against it, we can also use that visually to start assessing where some of the unusual numbers might lie. So I will see you back here in a minute. We will start building a histogram.